Here in this question on indices and logarithm, we are told that log to base 10 of 6 plus log to base 10 of 45 minus log to base 10 of 27, we are to solve it without using mathematical tables. Now, this is what we want to do. Since each of the entity is log to base 10, you can just write a single log to base 10, okay? And then by reason of the law of logarithm, here, since we are adding them, addition will turn to multiplication, subtraction will turn to division. So we have 6 multiplied by 45, then divided by 27. And what are we doing here? We're only applying the law of logarithm that is telling us that if you're adding logarithm of the same base, we can take a singular base, and for the addition we can multiply, for the subtraction we can divide. That is why we do this. So we can just go ahead and just simplify this. For example, 9 can go in 45, that is 5, okay? 9 can go in 27, that is 3. 3 here 1 and 3 in 6 is 2. So what we have inherently is log to base 10 of 2 times 5 is 10. 10 divided by 1 is also 10. And whenever you are seeing this, the logarithm of a number to the base of that number is nothing but 1. So in the first case, in this A, the solution is 1. Isn't that simple? Okay, that is quite interesting. In B, in this question B, we are told that 8 raised to the power x is equal to 32. And if we want to solve this, we can notice that 8 is actually a multiple of 2. 32 is also a multiple of 2. So if we want to write to the barest base, we can say 8 is 2 raised to the power 3. You see how that x, okay, is equal to 32 is 2 in 5 places, so it is 2 raised to the power 5. And by reason of this that we have, we can open up this bracket to say, therefore, what we have is 2 raised to the power 3x is equal to 2 raised to the power 5. Now, if you have questions like this, and we're seeing that the base are of the same value, this is 2 and this is 2, then that means that the powers, they must be equal. And in that case, we can just say this implies that 3x is equal to 5, and if we divide both sides by 3, that means x is nothing but 5 over 3. So that is also done and dusted, and we can go to our question C, in which we have 81 raised to the power 1 over 6 is dividing 27 raised to the power minus 1 over 9. Alright, this is also quite interesting. First and foremost, I can also see that 81 is 3 raised to the power some power. Ideally, 81 is 9 times 9. 9 itself is 3 times 3. So 81 is 3 times 3, which is 1 9, then multiplied by 3 times 3, which is another 9. So that is 3 in 4 places. I can say this is nothing but 3 raised to the power 4. Then this 1 over 6 raised to the power 1 over 6. Then divided by, okay, this is where it gets interesting. Now, for the 27 in itself is 3 raised to the power 3. 3 times 3 is 9, times another 3 is 27. So we know that. But what do we do with respect to this negative power that is at the base? When you're having negative power like this in indices, that means you're having 1 over, okay? So 1 over all the other values that we have, which is 27 will get to be 3 raised to the power 3, okay? Then we still have 1 over 9. So this is interesting now. We can just say, furthermore, trying to solve this, this will give us, okay, we can just open up the bracket like here. 2 can go in 4 is 2. 2 can go in 6, that is 3. Here, 3 can go in 3, 1. 3 in 9 is 3. So I can just say this is nothing but 3 raised to the power 2 over 3, okay? Divided by, let me just write this out first. Divided by 1 over 3 raised to the power 1 over 3. Okay, so this is interesting now. And we know that if you have division and want to solve it, what we are going to be having is that by the time we turn the division to multiplication, this will reverse. Numerator will go to denominator, denominator will go to numerator. So what we have here inherently is that we're having 3 raised to the power 2 over 3 multiplied by 3 raised to the power 1 over 3, because since we have turned division to multiplication, then this numerator and denominator, they must change. And this, we can just say we want to take one base. Since it's multiplication, laws of indices tells us that we can add the power. So we have 2 over 3 plus 1 over 3. And 2 over 3 plus 1 over 3, the same denominator, that is 3. 2 plus 1, that is 3. So this is nothing but 3 whole number, 3 over 3. So this 3 over 3 is 1. So we have it as 3 raised to power 1. And 3 raised to power 1 is actually 3. So the solution here is 3. And with that, our question here in these indices and logarithm had been done and dusted. And we got our answers as 1, 5/3, and 3. All right. That is just a foretaste of what this video is going to be looking like. We are going to actually have to prep you for any exam that's related to the grade 12 exam. Talk about your WAEC, NECO, GED, GCSE, IGCSE, and all of this is actually coming from our full treatment of the past question from the NECO 2021 General Mathematics exam paper. And so many topics are going to be featured. We've talked about indices and logarithms. We're going to talk about equations. We're going to talk about geometry, coordinate geometry. We're going to be talking about Venn diagram, bearing and distances, graphical solution to equations, statistics and probability, talking about group data, talking about ungrouped data. I'm going to be talking about word problems, sequences and series, and a whole lot of stuff. So we just wanted to pitch in, sit down, get ready, get your pen, get your paper, get your biro, get your calculator. I've been advocating that you get to be the best by actually walking along with what we are doing. You don't just get to be the best by watching. No. Beyond watching, you also need to get your hand dirty. That is what will build that proficiency in you. And if you are going to find this video useful, which you have had before this already, why not go ahead and just click the like button? And if you have not subscribed, go ahead and subscribe to DaveTuts Academy and turn on your notification bell so that anytime we upload videos like this, you are going to get notified on the fly so that you just make best use of it. And the mandate is for us to just prepare you for academic excellence so that you can become the best that God has prepared you to be. So we have our journey before us. We just want to pitch in, and then we know it's going to be quite a lovely journey. If you have any comment at all, just leave it in the comment section. We'll reply to all of them so that we can get an idea of what we are not doing well and also improve on what you believe we are doing well. And together, we know that excellence will definitely be our portion. So let's head over and continue our video for today. In this question, the equation of a line, we are told that a straight line passes through the point A, which is defined as 3, 0. So that means here, what we're having is x, y. X is 3, y is 0. And B defined as 2, -1. Again, we have it as s, y. So here, x is 2 and y is -1. So we have to look for the gradient of the line and the equation of the line. A picture is worth 1,000 words. So I just want to show us what this is looking like. And in this case, this first point A, which is defined as 3, 0, x is 3, y is 0. So this is the point that is A, okay, here, over 3, that is A. Then B is 2, -1, x is 2, here, and y is -1. So this is point B. And we have to look at that graph. That means we have something like this. So that graph will give us something of this order. Okay, so that is the straight line that they are particular to be asking us about. So first, they're asking us to find the gradient of the line. If we want to work within the confines of the value that we're given as A and B, we can just look at this, that this is going to be the gradient. So we can have the change in y-axis between 3 and -1 over the change in x-axis. But furthermore, for me, you can even just take it bigger. You can say you are looking at something like this, which you are looking at a change in y-axis divided by a change in x-axis. Either one, you see that you are going to get the same thing. But ideally, if you just want to use your equation as a guide to solve this question, you can just say the gradient in the first case, gradient, which is m, that we have to look for is change in y-axis over change in x-axis. So in this particular case, what is the change in y-axis? Y is the second one. So we can take B as the second case, or can take A as the second case. Whichever one we are actually given, you still arrive at the same answer. I want to make use of B as the second. So I'm going to say -1, which is the value of y in the second case, minus the value of y in the first case, -0, over the value of x in the second case, which is 2, minus the value of x in the first case, which is 3. So I'm going to have -1 minus 0 is -1, 2 minus 3 is -1. So the gradient, which is the slope, is nothing but 1, because here we are going to have it that minus sign, we cut out minus sign, so we have 1 over 1, and that is 1. The same thing could have gotten directly from the graph. that you can say that, okay, between this point A and this chord, if you just extrapolate the value, you see that you are going to get the same answer. So that is the gradient. In the second case, we're asked to find the equation of the line. Students, I want to quickly show you something. The general equation of the line is given as y is equal to mx plus c, where m is the gradient that we just got as 1, okay, and c is the intercept on the y-axis. So in this case, we have it as -3. So because of the understanding that I have of this question, I can just say my answer that I'm going to get is going to be nothing but y is equal to m, I got it to be 1. I don't need to write 1 as a coefficient of s, so I'll just say x, then plus c. I'm seeing from my graph that c is -3. I'll just say -3. And I know that this is going to be the answer that I'm going to get in this second equation, that the equation of the line is nothing but y is equal to x minus 3. But I'm only extrapolating that from the graph because I understood the concept of the straight line and I can pictorially view it on the graph and even sketch it out. But for you students out there who want to just get your hands dirty and work this out, so we can say out of the myriad of equation I want to use, we just want to get it out. And in this case, I will use y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1, okay? So I'm taking A as my 1 and B as my 2. So I'm going to have y minus y1. What is the value of y in the first one? I told it is x comma y, so y here is 0, y minus 0 over x minus, what's the value of x1 here? It is 3, okay? Is equal to, in the second case, y2 now is minus 1 minus y1 is 0 over x2 is 2, okay, minus x1 is 3. So this is what I have, and I have y minus 0 is nothing but y. I can also cross multiply y minus 0. Okay, let me just express it out first. Y minus 0 is y over x minus 3 is equal to minus 1 minus 0 is minus 1, 2 minus 3 is minus 1. And again, I can see that minus 1 will cut minus 1, and that will be 1. So that if I cross multiply, I'm going to have y is equal to x minus 3. And if you're observant, can you see that that's exactly what I extrapolated from the graph initially? So the understanding of all these simple techniques in mathematics can help you just sort out this question, and you'll be able to solve your question on the fly, and you are sure that yes, what I did was the right thing and I'm on my way to excellence. So we have gotten our gradient to be 1 and the equation of the line to be y is equal to x minus 3. Alright. In this question on mensuration of shapes, we are told that ABCD is a parallelogram with side AD given as 8 centimeters, side AB has 6 centimeters, and angle ABC at 60 degrees. We have to calculate correct to 3 significant figures, the area of triangle ABC and the parallelogram ABCD. So that will warrant that we really understand how to put in all these parameters into our parallelogram, okay? So if I look at the information that we're giving, like AD is 8 centimeters, so that should be either here or here because that's the longer side, okay? Then AB is 6 centimeters, that should be here or here. But looking at this angle, I think this will be the determining factor. That angle ABC is 60 degrees, so that is acute. It is less than 90. So the two angles that are less than 90 is either here or here. So for me, if I want to append that appropriately, ABC means it is at point B that we're taking that angle at 60. So I can say, let my B be here, okay? So this angle here now is 60 degrees, okay? Then I want to look at my AB, which is 6 centimeters. I have this and this as the option to pick. I'm saying that the shorter one is 6, so this should be 6. So I have this as AB, and say this is 6 centimeters. And then AD, so AD will be the next one. Of course, this cannot be C because we are giving AD, so I can say this is D, and then that will leave this place to be C. So these are the hints that can actually help you to get your question right because you're already interpreting the question correctly. And here I can say AD is 8 centimeters. And since you can interpret the question correctly, then you are good and fine. So what we asked to do was that here we are told that we are to find the area of triangle ABC. Wow. So even though it's a parallelogram, we need to first find the area of the triangle ABC. And to finish up so that I can get the triangle ABC, I can just join A and C with a straight line. So I have triangle ABC here that we're actually looking for. Since it's a parallelogram, the two parallel sides facing each other will be equal. So this is also 8 centimeters. And this AB will also be equal to DC. So this is also 6 centimeters. So we have to find, in the first case, the area of the triangle ABC, and by understanding of area and what we have, I think we can use half base times height, in which 8 centimeters is the base, but we need to get the height of this particular triangle ABC. We can go to point A and draw our straight line down. And we can say this is the H of this triangle. Okay, so if you look at this, okay, let me just call this point T. For us to get the area of the triangle ABC, it has to be half base. Base is BC, okay, multiplied by the height. The height is this 80, which is H. But if we look at this triangle ABT, we can see that H is opposite to 60 degrees, while 6 is the hypotenuse of that triangle. So consider that triangle is a right angle triangle, triangle ABT, and we want to use Socatua. If we want to use Socatua with that, we can see readily that this is the opposite and this is the hypotenuse. What is the relationship between opposite and hypotenuse? That is sine. Sine is opposite of hypotenuse, so we can say sine 60 is the opposite, h over hypotenuse 6. Therefore, our height is 6 sine 60, okay? So that the area of the triangle ABC that we are looking for is 1 over 2 multiplied by the base, which is 8, multiplied by the h, which is 6 sine 60. So this is what we need to put into our calculator. I will get the area out, and then we can evaluate it correct to 3 significant figures as requested. So let's bring out our calculator. We are going to have half, which is 0.5 times 8 times 6 sine 60. We close that bracket. So this is 12 root 3, or I can take it at 20.7846. 20.7846, but we are asked to get it correct to 3 significant figures. 3 significant figures will warrant that we look at this, and we're only going to take 3 digits, okay? So we can look at 2, 0, and then we need one more. We can take 7, but 8 is greater than 4, so we need to round it up to 1 and add to 7, so that will be 20.8 centimeters square. That is the area of the triangle ABC as requested. So in the second case, we have to find the area of the parallelogram ABCD. Okay, and this is nothing but the base multiplied by the height. Interestingly, we have gotten our height, and the base is 8 centimeters. So we can say this is just 8 multiplied by, what's the height? 6 sine 60. Okay, that is even 2 times the previous answer that we got initially, because this is having half as a coefficient, but this is not having half as any coefficient. So if you take our calculator, I could just say we want to delete this 0.5. So we have 8 sine 60, so that's 24 root 3, and that will be 41.5692. 41.5692. But again, remember that we are told to find the answer correct to 3 significant figures. So we can say we want to round it up to 3 significant figures. We have 4, we have 1. Those are 2 significant figures. 6, we round up to 1 and add to 5. So 5 will become 6 centimeters square. And with this, we've been able to solve this question on measuration and gotten our answer, because first we are able to interpret the question well to get our diagram, and then we can use the formula for area of triangle and then area of parallelogram, and we are good and fine. We had this question on word problem in which we are told that a village P is 12 kilometers from village Q, and it takes 3 hours 20 minutes to travel from Q to P and back to Q by a boat. So that is both the to and the fro journey. It is taking 3 hours 20 minutes. So we're now being told that if the boat travels at a speed of 6 kilometers per hour from P to Q and 6 plus x kilometers per hour back to P, we are to find the value of x. Let's look at this distance that we are looking at. We are saying first is moving from P to Q, and for that it is going at a speed of 6 kilometers per hour, okay, and then back from Q to P. So we are having a return journey, and that is taking 6 plus x kilometers per hour. So our mandate is to find x. Let's look at all the parameters that we are given. The total time that we are given was 3 hours 20 minutes, but we cannot actually be working with 20 minutes because look at the question. The speed is given as kilometer per hour, so we need to express that 20 minutes as hour. It will be 3 whole number 20 over 60 because 60 minutes makes 1 hour. So 20 can go here 1, 20 can go here 3. So this is 3 whole number 1 over 3 hours as the total time that we are looking at for this journey to and fro. Okay, that is the journey both from P to Q and from Q back to P. So that's the very first thing that we need to note. Then from understanding of speed and distance, we know that if you are giving speed to be distance over time, if you cross multiply, you can say time is also distance over speed. So if you want to look at the journey to and fro, in the first case, the journey from P to Q, the time from P to Q is going to be the distance, which is 12 kilometers, over the speed, which we are given as 6. So this is 2 hours. Okay? If that is 2 hours, from Q back to P will be the total time, which is 3 whole number 1 over 3, or I can say it's 3 times 3, 9. 9 plus 1 is 10. 10 over 3 minus 2. So what I'm saying is that the journey from Q back to P will be the total time, which is 3 whole number 1 over 3 hour minus the time taken from P to Q, which is 2 hours. So if you want to solve this, you can find the LCM. This is 3, 10 minus 3 times 2 is 6, so we have this as 6, so that it will be 4 over 3 hours. So 4 over 3 hours is the time taken from Q to P. But from this particular formula, that time is distance over speed, and the distance from Q to P is still the same, so we can have 12 over, what is the speed? The speed is 6 plus x here that we are giving here, okay? So we can have 6 plus x, that is equal to 4 over 3. So here we can just say we want to cross multiply, and that will give us 12 times 3 is 36. So we have 36 is equal to 4 times 6 is 24, and 4 times x is 4x, such that 4x will be 36 minus 24, and 36 minus 24 is nothing but 12. So 4x is equal to 12, and therefore our x that we are looking for will be 12 over 4, and that is 3. So what is going to be the unit of x? You can see that x is being featured in brackets, and the unit appended to that was kilometer per hour. So the unit of x itself will also be kilometer per hour. So this is the value of x that we are asked to find from this word problem, that is a journey from village P to village Q. Alright. Yeah, in this question on quadratic equation, in which we are asked to find the equation whose roots are 2 over 3 and 3 over 4, there are two methods we can go about trying to solve this. In the first case, we can make use of the general equation that x squared minus sum of roots alpha plus beta multiplied by x plus the product of roots alpha beta is equal to 0, in which alpha and beta are the roots of the equation. So in this case, you can say alpha is 2 over 3 and then beta is 3 over 4. So if you have that, we can just make use of alpha plus beta to say will be nothing but 2 over 3 plus 3 over 4. And in that case, we can find the LCM, which is 12. That's 3 multiplied by 4, that's 12. 12 over 3 is 4. 4 times 2 will be 8, plus 12 over 4 is 3. 3 times 3 will be 9. So this will be 8 plus 9 is 17 over 12. Okay. Then alpha beta, the product of roots will be 2 over 3 multiplied by 3 over 4. So this will be 6 over 12. Okay. So if we want to use that in the equation, we can say that means we have x squared minus the sum of the roots, that is 17 over 12 multiplied by x, then plus the product of the roots, that is 6 over 12. And you will notice that I didn't change the value of the denominator because in this case I can multiply all through by 12 to say 12 can multiply everything on the left hand side, and of course 12 multiplying everything on the right hand side will still be 0. So in this case 12 times s squared will be 12s squared. Okay. If I'm saying 12 times 17 over 12, the 12 will cut out this 12, so I have minus 17x. Then in the same case, 12 multiplied by 6 over 12, this 12 will cut out, so we have only 6 remaining, so we have plus 6 is equal to 0. So this is as good as it gets, but that's not the only means by which you can choose to solve this question. We can also say we want to look at a scenario in which the roots being 2 over 3 and 3 over 4 means that x is equal to 2 over 3 or x is equal to 3 over 4. So we just want to work our way backwards from the situation in which we are working with means of maybe factorization means of solving the question. So here, if you cross multiply, we can say this means 3x is equal to 2, or we have 4x is equal to 3. That is just by cross multiplying. And then if you just take everything to the left hand side, in this case we have 3x minus 2 is equal to 0, or 4x minus 3 is equal to 0. So if you have this, that means these are the two factors that we're eventually solving, that if we are bringing them together, we can have 3x minus 2 multiplying 4x minus 3 is equal to 0. So we just need to open up this bracket now. 3x times 4x is 12x squared. 3x times minus 3 will be minus 9x. Minus 2 times 4x will be minus 8x. Minus 2 times minus 3. The negative signs will multiply to become plus. 2 times 3 will be 6. And this is 0. So if you just want to simplify this, this is 12x squared. Minus 9x minus 8x will combine to be minus 17x. Then we have plus 6 is equal to 0. And you can see in the same vein, we are actually arriving at the same answer that we got the other time. And whichever method you want to use in the exam, just be consistent, work out your question, and you'll see that you will arrive at the correct solution. Alright. In this question on differentiation, we have to differentiate y is equal to s squared over 1 plus s squared with respect to s. And we can see that we have a numerator and a denominator. This is best solved by saying that we have y to be u over v, such that we will have our differentiation to be the differentiation of y with respect to s. As standard rule will be v du dx, okay, minus u dv dx divided by the square of v. Now, in this particular case, what we are noticing is that since you are saying y is u over v, that means our u is s squared, and in that case, du dx, the differentiation of u with respect to s will be 2x as standard differentiation, and then v we are taking as 1 plus s squared, and then dv dx is also differentiation of a constant is 0, so differentiation of 1 is 0. Differentiation of s squared is also 2x. How are we differentiating? We are saying that if y is a multiplied by x raised to the power n, then the y dx is going to be nothing but this coefficient multiplied by that particular power, then you have x and you reduce the power by 1. So that is the means by which we are differentiating here. And if you want to put in all these values here for u, v, du dx and dv dx, then we can say that the differentiation of y with respect to x will be nothing but v. What is our v? V is 1 plus S squared, multiplied by du dx is 2x, okay, then minus u itself is S squared, multiplied by dv dx is 2x, so multiply by 2x, then we are dividing by v squared is 1 plus x squared, okay, so we now raise it to the power of 2. So this is what we need to simplify. Open up the bracket and see what that is going to give us. So we can say the y dx is nothing but 2x times x is 2x times s squared. We have x raised to the power 2 and s raised to the power 1. We can add the power. So we have it to be plus 2 as a coefficient, then x raised to the power 3, which is 2 plus 1, okay? Then minus here, again, we're having x squared multiplied by 2x. It's going to be 2x3, just like we did initially. Then we are dividing by 1 plus s squared raised to the power 2. So we can see in the numerator that 2x3 minus 2s3, they will knock out. So this will give us 2x over 1 plus s squared raised to the power 2. So inherently, what we are asked to find that the differentiation of y with respect to x is this as 2x over 1 plus s squared raised to the power 2. This is our final solution and our answer is out and done. Here in this case, we have to solve this particular equation that 2 over 3 multiplied by 3x plus 2 is equal to 3 over 4 multiplied by 2x minus 3. And as a rule of thumb, what I will solicit that students should do, look at 3, look at 4. These are denominators. You can choose to cross multiply, or you can choose to multiply both sides by the product of these 3 and 4 that are the denominator, okay? Whichever one is suitable for you. If you say, okay, 3 multiplied by 4, that is 12. So I want to multiply both sides by 12 multiplying all of this, and 12 also multiplying all of this. In that case, you can see that 3 can cut 12 to give us 4, and 4 can cut 12 to give us 3. So if you open up this now, 4 times 2, that is 8, into bracket 3x plus 2 is equal to 3 times 3, that is 9, into bracket 2x minus 3. It's the same thing as if you just want to say you want to directly cross multiply, that 3 times 3 is 9, so you have 9, 4 times 2 is 8. We are still going to arrive at the same thing. So we can now open up our bracket. 8 times 3x is 24x, plus 8 times 2 is 16, is equal to 9 times 2x is 18x, minus 9 times 3, that is 27. Here, you can just collect like terms to put the variables on the left-hand side. So we have minus 18x is equal to minus 27, and when 16 goes to the other side, it becomes minus 16. So 24x minus 18x, that is 6x, is equal to minus 27 minus 17. Minus 27 minus 16 will be minus 7 plus 6 is 13, remaining 1. 2 plus 1 is 3. With that one, we have 43. So if we are to divide both sides by 6, x will be minus 43 over 6. And this will be, 6 can go in 43, then that will be 7. 6 times 7 is 42. 43 minus 42, that is 1 over 6. So we have our answer to be minus 7 whole number 1 over 6 as a solution to this equation that we are asked to solve. Alright. We have this question on statistics of grouped data. So it is grouped because you can see that already there's a tabulated value in which we are grouping a set of values, a set of mass in this case, together, and we are looking at the number of occurrences, that is the frequency in which they occur. So we have this particular table showing the mass of logs of wood to the nearest kilogram, and our mandate is to calculate the mean and the mode. I would have actually loved that they asked us the mean, the median, and the mode, but no problem. Let's work within the rotation of what we are given. Now, in this particular question, for us to find the mean, that will just be quite straight and direct. But because we are looking for the mode, we are looking for the most occurring mass among all these data entry, we need to tabulate our result and formulate some data sets that will be useful for us to estimate the mode of this particular data that we have. So this is what that table will look like, and I will just do some so that we will see how this is done. First and foremost, we need to replicate this data entry into this particular table, Our interest is the data set, which is the mass, the frequency, the number of occurrences. We are going to get the median value of that particular mass because it's actually a range from 31 to 40. We need to get the midpoint of that class, and we can multiply the frequency and the midpoint of the class as fx. Then the class boundary, we need to find the upper and the lower class boundary, and this is how we go about that. First, let's tabulate all the data entry, and we just do that as given on the go. The frequency we have also been given, we just need to replicate that. Now, for us to get the midpoint of this particular data set, we need to look at something sort of like the median of this particular data entry. Like we are having 31 plus 40 divided by 2, that will be 71 over 2. So what's the median of this? 2 in 7 is 3, and that will be 2 times 3 is 6, remaining 1. 2 in 11 will be 5.5. So the midpoint for the first particular set of data grouping is 35.5, and I'll just show you something now. Add this as 35.5. If you are consistent, you see this as 45.5, 55.5, 65.5, 75.5, and 85.5. You can check that out and you see that this is the midpoint of this particular data set that we have. Now, for us to get our fx, we just need to multiply all through the frequency multiplied by x. That is going to give us fx, and I'll just do like 3 times 35.5. So we have this as 106.5. So we have this as 106.5, and you can just do the others just like that. Now, for us to get the class boundary, just look at the last entry in this particular first data set and the first entry in this, and try to find the midpoint between them. Okay, that midpoint in this case is going to be 40.5. So what you have with this as 40.5 is just that in the first case, you can see that at the upper class boundary, we are adding 0.5 to 40, and at the lower class boundary, you are going to subtract 0.5 from 31. You have it as 30.5 to 40.5. And then the next one will just kickstart from that, 40.5 to 50.5, then 50.5 to 60.5, then 60.5 to 70.5, 70.5 to 80.5, and then 80.5 to 90.5. So that is what we are going to have as a means of generating our table of values. Then we can go to our question originally, as we are asked that in the first case we are to find the mean, and here is the formula for the mean. It is a summation fx over summation f. This is our fx here, that is fx. So we have to sum all of these together to get the total, and then we divide by the summation of f. Okay, so can just take our calculator to try and compute that. Fx is what we want to sum now, and for that we have 106.5 plus 455 plus 832.5 plus 786 plus 453 plus 342. So what is that sum? 2975. So I can say here what we have is nothing but 2975 divided by the summation f. You can say 3 plus 10 plus 15 plus 12 plus 6 plus 4. So that is 50. So we have divided by 50. So our mean that we are looking for is nothing but 2975 over 50. So we have 2975 divided by 50. So this is 59.5. So the mean is 59.5. And what's going to be the unit? You can see is mass we are talking about here, and this is measured in kilogram as given. So the mean of this data set is 59.5 kilograms. So this is the easy part. We now need to look at how we can evaluate our mode. So for us to be able to get our mode, this is the formula that we're going to be making use of. You don't need to fret at all I'm going to demystify all of these terms, okay, and we're going to work them out together. In the first case, the LL is going to be the lower limit of the modal class, okay, and the modal class is the class that where we have the highest occurrence of data entry. It's going to be the class with the highest frequency, and for this you can identify it that this is a class of interest that we are talking about. Is this 51 to 60? That is going to be our modal class, and its frequency is 15. So we are talking about the lower limit. That lower limit means that we need to look at that modal class as featured here, okay, and that lower limit you can see from the class boundary, from lower limit to upper limit. The lower limit is 50.5. So you can have our LL to be 50.5. all right. So we want to evaluate theta 1. What is theta 1? Theta 1 is going to be the difference in frequency between the frequency of the modal class and the frequency of the class before it. Now we have seen that here this is actually the frequency of our modal class. The frequency before it is 10. So theta 1 is going to be 15 minus 10, and that is going to be 5. Okay. Theta 2 is going to be now the frequency of the modal class minus the frequency of the class after it, and that will be 12. So we are going to have 15 minus 12 here, and this is going to be 3. Okay. Then the C is going to be the class size, and you can get that by subtracting the lower class boundary from the upper class boundary. Maybe we can say 40.5 minus 30.5 if you want to use that first class, or 60.5 minus 50.5 is going to be the same thing. So that is 10. It is 60.5 minus 50.5, and that is 10. So these are the parameters that we need to solve this holistically, so that we can say our mode for this particular question set is LL, which is 50.5, plus theta 1 is 5 over theta 1 plus theta 2, that will be 5 plus 3, multiplied by the class size, which is 10. So you can say our mode is nothing but 50.5 plus 5 over 5 plus 3, that will be, okay, 5 times 10 is 50, 5 plus 3 is 8. I think we can just get this out straight, that our mode is nothing but 50.5 plus 8 in 50, that is 6. 8 times 6 is 48. So we have 2 remainder. 2 over 8 is 1 over 4, and that is 0.25. So our mode is going to be 50.5 plus 6.25, and that will be 56.75. And what's going to be the unit is going to be kilograms. So the mode in this particular group data that we're actually given is nothing but 56.75. all right. In this question on geometric progression under sequences and series, we are told that if the second term of a GP is 6 and the fourth term is 54, we are to find the first term and the fifth term. So, as a reason of a recall of our understanding, the nth term of a geometric progression is given as the first term A multiplied by the common ratio raised to power n minus 1, where n is the number of terms. Okay, so in this particular question, we already told that the second term T2 is 6, and then the fourth term T4 is 54. Okay, what we need to note is that if we want to apply this particular formula, we need to say that T2 is nothing but the same as A, which you don't know yet, multiplied by the common ratio, which you don't know also, then raised to power n minus 1. Since we are talking about T2, n is 2, so we have 2 minus 1, and that is 1. We don't need to write 1, okay? And then for T4, it's going to be A, the first term, multiplied by r raised to power 4 minus 1. So we have 4 minus 1 here. Okay, let me just write this as 2 minus 1. So if you want to reflect that really, these two, you can now say that that means that AR is equal to 6, because 2 minus 1 is just 1. We don't need to write that. Then AR raised to power 3 is equal to 54. So these are two equations that we can have here, equation 1 and equation 2. To solve this, since it is actually a product, it will be best that we divide. So you can say equation 2 divided by equation 1, and that is going to give us nothing but AR raised to the power 3 over AR is equal to 54 over 6. Okay, and then from here you can see that A is cutting out. 6 can go here, 6 can go in 54, that is 9. So what we have inherently is that R3 over R, which is the same as a single R, 3 minus 1 is equal to 9. So 3 minus 1, this is applying the laws of indices anyway. 3 minus 1 means that we have R raised to the power 2 is equal to 9. And therefore R is going to be the square root of 9. Now notice, students, square root of 9 is not just 3. It is plus or minus 3. Okay, so you should know that. That means for this particular question, as you are getting the solution for the positive 3, you also need to be getting the solution for the negative 3. Okay, so we are noting R to be then. We know that AR is 6, therefore A will be 6 over R. In the first case, when R is 3, A will be 6 over 3. And then in the second case, when R is minus 3, A will be 6 over minus 3. So we have A to be 2 or A is minus 2. Just like we have R is 3 or minus 3. Okay, so that being said, we can now say we want to go and look for whatever nth term that we are being asked to get. Like in this case, we are asked to find the first term and the fifth term. Okay, so that is good. We have gotten the first term, that the first term can be either 2 or minus 2. And that is very, very good. Then for us to get the fifth term, let me just clear some section of this board. So we can see that we have two sets of data value. In the first case, we have one in which we have our A is equal to 2 and then R is 3. And then in the second case, in which we have our A to be minus 2 and R is minus 3. So even for the first term, we are going to be saying that A is 2 or minus 2. And then in this second question, in which we are also being asked that we have to find the fifth term T5. T5 is AR 5 minus 1, which is AR raised to power 4. So it's either we have it as, for the first case, you can say T5 is equal to A is 2 multiplied by R is 3 raised to power 4. So this will be 2 times 81, and that will be 162. Okay, or that's not the only case, or we can say our T5 is also A in the second case with this second option minus 2 multiplied by minus 3 raised to power 4. Okay, so since this is an even number, the powers of minus 3 will still be positive, but we now have minus 2 as the coefficient multiplied by 81. So this will be minus 162. So these are the possible solutions that we can have, that T5 can be 162 or minus 162, and the first term A can be 2 or it can be minus 2. And with that, we've been able to solve this question. Don't just take the square root of 9 as 3 and think you are getting your correct answer. You're only going to get half of the math, because square root of 9 is not 3, it is plus or minus 3. Okay, so just know that, and once you are able to pick that, you solve your question, you are good to go and your full mark is assured. Alright. We have this question on set theory with Venn diagrams, and we're told that in a school of 160 pupils, 75 have pencils, 87 have pens, 93 have rulers, 25 have both pencils and pens, 30 have pencils and rulers, while 47 have both pens and rulers. Each pupil has at least one of the three items. Our mandate is to first draw the Venn diagram to illustrate this information, and then to find how many pupils have pencils only. So for this particular question, we are going to be using P as our pencils, Q as our pen, and R as our ruler. And our very first mandate is to define all of this information that we have here, which we are going to be doing right about now. That in the first case, the number of pupils, which is the universal set we are looking at, is 160. Okay, and then we are told that 75 have pencils, so the number of those with pencils is 75. And then the number of those with pens, which we are denoting as Q. So you see, Q is denoting pens, is 87, alright. Then the number of pupils that are actually having rulers were given as 93, so we can tag that as 93. Then we have the intersections, like here, 25 have both pencils and pens, so the number of pencils intersect pen were given as 25, okay. And that's not all. We're also told that 30 have both pencils and rulers, so P intersect R, number of those having pencils and ruler is given as 30, and then 47 have both pens and ruler, so number of students with pens, which we denote as Q, and ruler is given as 47. So these are the information that we're given that we're expected to also put in the Venn diagram, and then we need to know that the fact that each pupil has at least one of the three items means that all of the pupil will be included either within P or Q or R, or the intersection of them with one another. None is going to be outside that combination of P, Q, and R. So that is that information. And as a rule of thumb, I generally prefer that we should start at the intersection of the three subsets that we are looking at. And you can see in the details that we are giving, we are not giving the detail of those pupils that has all three items that we are looking at. So since we are not giving, we can do well to call that X, okay. So having done that, we can work our way outwards since we are starting from the center. Now let's look at the intersection of each one of them. Like in the first case, we want to look at the intersection of P and Q. P and Q, you need to know that will denote this region. This is P and Q. These two is the one that is common to both P and Q here. But if you notice from that already, we have gotten X out. So the remaining here that is in green will be that 25 that they denoted as P intersect Q. This two is 25. But if we take X out of it, this remaining here that is still in green will have to be 25 minus X. So you can say here, what we have here is 25 minus X. And that same rule we can apply to other intersection points. Like for example, we have the number of P intersect R. This is P intersect R. It is given as 30. So here and here is given as 30. But since we are taking X out of the equation, intersection of Q and R was given as 47. If we take X out, this region will be 47 minus X. Okay, so this is actually a very good means that can simplify your work for you. Now, if you look at the question, we are not giving information about those that have pencils only, and also we are not giving the information about those that have pens only, also not giving information about those that have rulers only. Okay, since we are not giving any of those, I would like to call those regions. Let me call this A, that is pencil only, B is pens only, and then C will be rulers only. But don't forget, we are giving P itself to be 75. So P here, this is 75. Q we are given to be 87, okay, and then R we are given to be 93. So with this information that we have here, the onus will now lie on us to make use of all this information and get out the solution to get the number of pupils that have pencils only, and that pencils only will be A, okay. Since P is our pencil, A will be pencil only. They only have pencils, they don't have rulers, and they don't have pens, okay. So having interpreted our question already, we are seeing that we have 4 variables, 4 unknowns, and these are tagged as here. We have A, B, C, and X. A, B, C, and X that we are looking for. And to solve this holistically, we need 4 formula A that will help us to actually solve this holistically, so that particularly what we are being asked, the number of pupils that have pencils only, which we have identified as A, we can get that out easily. But first, we need to formulate our formula A that will help us to solve this holistically. We are seeing that we have some subsets in this particular Venn diagram. In the first case, we have been given the total number of pupils that have pencils as 75. So if we add all the regions of pencils, A, 30 minus X, X, and 25 minus S, we can equate it to 75, and that will give us one equation. Okay, we can do the same thing with Q, those pupils that have pens, and we can do the same with R, those pupils that have rulers. That is going to give us a set of 3 equations, but our fourth equation will warrant that since we are given the universal set, and we're told that each pupil has at least one of the 3 items, already we know that outside of these 3 subsets, no pupil is going to be there, but we have the universal set. So if we add all the entries, this region, this, here, and here, if we add all of them, it's also going to give us 160, and that will be our fourth equation. So what we are going to do right now is just to put all those out and see where it's going to land us. In the first case, for the number of p, we have a plus 25 minus x here, 25 minus x plus this x, then plus the last region, 30 minus x. The total of them is actually the number of pupils having pencils, which is 75. So we are getting this from our number of pupils having pencils. And if we look at this critically, we can see that minus x and plus x, they will cut out. So we have for unknowns a and minus x, a minus x, 25 plus 30, that is 55. When 55 move to the other side, we have 75 minus 55. So this will be equal to 20. I can call this my equation 1. And in the same way, we can do for Q, that look at the entries in Q. B, 47 minus S, 25 minus S, and X, they all add up to be 87. So I'm going to have B plus 25 minus X plus 47 minus X is equal to 87. I'm getting this as a reason of the number of pupils that are having pens. Okay, so if I want to also simplify this, I can see that minus x and plus x, they are cutting, and b minus x are b minus x is equal to 25 plus 47, 5 and 7 is 12, 2 and 4 is 6, plus 1, that is 7. So I have that as 72. When 72 moves to the other side, I have 87 minus 72, so that will be 15. So this is equation 2. Okay, and then in the third vein, if I consider those pupils with rulers, I will also add each of these entries. So I'm having c plus 30 minus x plus x plus 47 minus x is equal to 93. This is the number of students, number of pupils that are having rulers. And again, in trying to simplify, minus x and plus x, they are out. We are left with c minus x as our variable. Then 30 plus 47, that will be 77. And when 77 moves to the other side, that will be 16. So I have 16, and I can call this my equation 3. Okay, but that is not all. I already told us that we have 4 unknowns, so we need 4 equations, and that last one will be the addition of all of these entries, equating them to 160 as universal set. So in that case, we have, let me just put it together as a plus b plus c, a, b, c. Then we have x here plus x plus 25 minus x plus 30 minus x plus 47 minus x. Everything is equal to 160, and this is a statement of the universal set. So what I have here eventually is that, look at this. This is plus x, this is minus x. They take themselves out. So I'm left with a plus b plus c. Then I have minus x and minus x, so that will be minus 2x. Then 25 plus 30, that is 55. 55 plus 47, that will be 102. So I have plus 102 is equal to 160, such that a plus b plus c minus 2x is equal to 160 minus 102. That will be 58, and I can call this equation 4. So I have these 4 equations, and of course I have these 4 unknowns also that I can try to solve out to get the solution to this particular question. And I'm seeing a symmetry. Look at this. I'm having a plus b plus c here. Okay, now if I add equation 1, 2 and 3, I can get a plus b plus c already. So those 3 a plus b plus c, here it will be minus 3x is equal to the addition of all this. I can actually combine with this equation to first solve for x, and that is what we are going to do exactly right about now. Okay, so these are the set of equations that we have already. If I add these three equations together, equation 1, 2, and 3, we are going to have a plus b plus c. So we have a plus b plus c. Then minus x plus minus x plus minus x will be minus 3x. Then 20 plus 15, that is 35. 35 plus 16, that is 51. So this is 51. Let me call this equation 5, gotten from the addition of equations 1, 2, and 3. Now, if you look at this particular two equations, equations 4 and 5, you can see that, let me just say, I want to subtract them, okay? Here, I'm going to be subtracting. I want to subtract equation 4 minus 5. A plus b plus c, we subtract a plus b plus c, and that will be null. Minus 2x minus 3x will give us something like this. I have minus 2x minus 3x. That's going to be 58 minus 51. Okay, so that is making our work look interesting, because this will be minus 2x plus 3x is equal to 58 minus 51. That is actually 7. So minus 2x plus 3x means that x is actually 7. So the number of pupils that have pencils, pens, and rulers, x, is actually 7. But that's not what we're asked to get. What we're asked to find is that how many pupils have pencils only. So the number of pencils only, we can see that we denoted it as a. And looking at this equation, we can see that equation 1 is saying a minus x is 20. So from that equation 1, we can say we have a minus x is now 7 is 20. Therefore, a is 20 plus 7, and that is 27. And our a, you can see, is the number of pupils having pencils only. So we hope this had actually gone a long way to help you understand how to solve this particular type of questions on set theory, particularly with Venn diagrams. You don't need to be stereotyped. You don't need to be adaptive to the question, and then use your ingenuity. Like here, we are coming with an understanding of the fact that to solve a number of equations, you will need the exact number of equations as the exact number of variables that you are trying to get. So we have 4 variables, and for us to be able to get that, we need 4 equations. So we're able to postulate the equations that we can get. We also need to get the other value, like b. You can see from here, from equation 2, b will be 15 plus 7. That will be 22. C will be 16 plus 7, okay? And that will be 23. So you can just get everything out, and you can get whatever they wanted to ask. Once you have all these variables, you don't know them, they are no longer unknowns, they are knowns to you, then you can be good and fine, and your work will be done and dusted. In this question on parallel lines and the intercept, we are asked to use the information in the diagram to find the value of x as shown here. So this is what we are looking for, that is x. And looking at this diagram, we can make use of understanding of corresponding angles and alternate angles, whichever one will be suitable for us to try and solve this question as appropriate. And this is what I just want to do. For this particular line, if I want to extend this from here, okay, what I will need to notice first and foremost is that this angle here is also going to be 47 degrees, because it is corresponding to this angle. This is corresponding to the angle at C, which we can say is angle ACD. Okay, if we're looking at this angle also, this is 83, okay, and it's also corresponding to this angle coming from up here to A to B. That 83 degrees is corresponding to the angle at A, okay. So if you want to get how that is, you can see at A we are having something like this, okay, in which it is also just replicated here, and then this 47 degrees is also just look at this. It's also looking like that angle. They are having the same shape. They are facing the same sides. So they are corresponding angles to one another. And then at D, after having done all this, you can see that at point D, at the vertex D, you can see that 47 degrees plus x plus 83 degrees, they are angles on a straight line, and the sum of angles on a straight line is 180 degrees. So we are saying this because they are the sum of angles on a straight line. Okay, since we have that as our postulate, we can now say 47 plus 83, that will be 130. So x plus 130 degrees is equal to 180 degrees, and then x itself can be 180 minus 130, and 180 minus 130 is nothing but 50. So the solution to this question is that x is 50, and this is just one of the ways that you can choose to do it. You can also choose so many other means. You can move your angles here, you can find this angle, okay, and you can also find this angle, and you see that it will also record to the same, because here this 47, this is also 47, and then because this line and this line, they are parallel, this AD will be a transversal across them. So here, this will also be x. In this case, x here and x here, they are alternate angles. And 47 here and 47 here, and you still see that 83 plus 47 plus x, they will still give you 180, and you still arrive at x as 50. So whichever method you think is suitable for you, you can use to solve this question, but you eventually get that x is nothing but 50 degrees. We have this question on bearing and distances, in which we are told that a boat sails 6 kilometers on a bearing of 040 degrees and then 8 kilometers on a bearing of 100 degrees. We have to find how far the boat is from its starting point and to calculate the bearing of the boat from its original position. Our answers will be to the nearest kilometers and degree. Let's look at the very first statement, that it is moving 6 kilometers on a bearing of 040 degrees. 040 degrees is going to be in the first quadrant, so we can have a diagram putting that in consideration, that we have north, south, west, and east. Here we are going to have east, okay? And then we want to look at a scenario in which the movement is on a bearing of 040 degrees. So this should be something like this. Now, from this new position, it also moves 8 kilometers on a bearing of 010 degrees. Here we can also consider our cardinal points, north, south, east, and west. And then we are moving on a bearing of 100 degrees. 100 degrees will just be a bit more than 90, and 90 is from north to east, which is the right angle. So we'll have something like this. But that is now 8 kilometers, so it should be longer than the 6 kilometers that we just drew. And then we can say maybe we want to finish up our diagram just like this. Okay, I think that's a good pictorial view of what we are looking at. So we can now label that, okay, this is starting point. Let me call that A. To this point, I can call that B. Then to the final destination, I can call that C. Distance between A and B, we are told is 6 kilometers. So this is 6 kilometers. Between B and C, we're given as 8 kilometers. Okay. Then the bearing, we are told that from A to B is on a bearing of 040. So we want to know that appropriately. Let's say this is from my north. So I'm going to have 040. So from here to this inclination is 040. Okay. And then in the other case, we have the bearing from B to C was 100 degrees. So from here to here, this is 100 degrees. So this is our diagram. What we're asked to look for first is how far the boat is from the starting position. That is distance CA. Because this is A is the starting position, is ending at C. How far it is this distance between A and C. Now, since it is facing the vertex B, this will be small b. Since A is facing this particular side, BC, 8 kilometers is going to be small a. Then since C is facing this particular side, AB, this 6 is going to be C, the side facing the vertex, okay? Now, looking at this diagram, we have a triangle in which you don't know any of the included angles. But for us to solve, we need to know at least one of those included angles. So we'll try and see how we can get that. But looking at the point B, this is looking as our sure bet, because already we have this as 40. And we know that by reason of the rules of parallel lines and co. That 40, if you come here and also come down, this is also 40 as alternate to this 40 that was the bearing of B from A. Then from north to south is 180 degrees, but already we have the inclination of C from B to be 100. So what will be remaining here will be 80, such that that 80 plus 100 will be 180 degrees angle on a straight line. So we can compute this particular angle at B at the addition of 40 and 80. So you can say this here is nothing but 40 plus 80, which is 120 degrees, the one facing this B. So we have this particular set of parameters, and we're going to see how we can solve them to get how far the boat is from a starting position. We are looking for this B, and we can see that we have the angle facing B, then we have the sides flanking those angles, 6 kilometers and 8 kilometers. In this particular case, our best bet is to use the cosine rule. And the cosine rule, if you are looking for B, is saying that B square is going to be A square plus C square minus 2AC cos the angle at B, which is cos B. So we have all of these parameters. A is 8 kilometers, C is 6. The angle at B is 120. So if you just put in all those parameters, we can say B square is going to be, our A square is 8 raised to power 2 plus C is 6. So we have that raised to power 2 minus 2 times 8 times 6 cos angle at B is 120 degrees. So this is the square of B. Mind you, you can now say we want to input that to the calculator. 8 raised to power 2 plus 6 raised to power 2 minus 2 times 6 times 8 cos 120 cos 120. So this is what? This is 148. So B raised to power 2 is 148, and B itself, this is B raised to power 2. Therefore, B itself is the square root of 148. And we can say that B will be, if we are to look for that square, we can say the square root of the answer that we just got, that is 2 root 37 or 12.1655, 12.17. So we can say B is 12.17 kilometers. But look at the question. We said we're asked to leave our answers to the nearest kilometer. So if we want to round this up, we can see that 1 is the number after the decimal place. We'll round it down to 0, and then this will just be 12 kilometers approximately. So for my B, if I want to note it, I will not note it as 12. What we got is 12.17. So this is the solution to the first question to get how far the boat is from its starting position. In the second question, we're asked to find the bearing of the boat from its original position. That bearing, this is the final destination C. Its initial position, original position is point A. So the bearing we are looking at will be from the north to the inclination of C from that north. So we can call that theta. If we look at this angle very, very critically, we can see that theta we can actually get by adding 40 to the angle here. So you can get this angle at A, you can get this angle. Okay, we'll just know that our theta that we are looking for is going to be 040 plus that angle at A. So if you are to do that, we'll have it that A over sine A is equal to B over sine B by reason of the sine rule. And what we are looking for is actually sine A. So in that case, we can just say sine A is going to be nothing but, here we would have cross multiply. So we have A sine B over B. So sine A will give us this value that, what is the value of A? It is 8. Sine B will be sine 120 over B. B itself is 12.17. We use the original value we get, not the approximated value. Okay, so we can say sine A is equal to, so we can say sine A will be 8 sine 120 divided by 12.17, 0.5693. So this is 0.5693, and then A itself will be arc sine 0.5693, and that's going to give us shift sign. The answer we just got, 34.7. This is 34.7. But like I said the other time, the angle we are looking for, that's theta, is going to be 40 plus the angle at A. It will be 40 plus 34.7, and that will be 74.7. Now, we're told in the question that we should leave the answers to the nearest degree. And as a rule of thumb, you don't leave the bearing as decimal place. You don't even leave it as 2-digit numbers. You need to leave it as 3-digit numbers. So just like they are giving us in the question, you have 0 for 0. So like this, if you are to round this up, okay, 7 will round up to 1 and add to first, that will be 5. So making it 75. But as a bearing, we need to write it as 3 digits. So we have 0.75 degrees. So this is the solution in the second case. And holistically, we've been able to look at this question of bearing and distance, get the diagram accurately, solve for the unknown distance by making use of the cosine rule, and look at the triangle, use the sine rule to solve for the included angle, and then just oppose out the bearing as requested, and we are good and fine. Here in this question on calculus, we are asked to find the area enclosed by the curve y is equal to 2x squared plus 3, the x-axis and the ordinate x is equal to 2 and x is equal to 1. And this is just the view of what the graph will look like. I just extrapolated the value of y is 2x squared plus 3 when x is 0, when x is 1, when x is 2, and when x is 3, and then got this particular graph. So what we are being asked to get inherently is the area that is enclosed by that curve, this curve in red, okay, the x-axis at the horizontal, okay, and then the ordinate x is 2 here when x is 2 and when x is 1. So the shaded region here is the area that we are asked to get. Now, if you look at that region critically, you will discover that this is nothing but approximately the area of a trapezium, in which you can find as half multiplied by the sum of the parallel sides. Because I was able to extrapolate this, those parallel sides, when x is 1 and when x is 2, the value corresponds to y to be 5 and y to be 11. So it's something like 8 square unit that we're going to get as the area of the trapezium. But you know, that is an approximation. It's actually a curve we're looking at. So we'll just do well to look at means of calculating that as requested. So what we're expected to do is to find the area under the curve, and for this particular case, it's giving us the integral from the lower limit here, which is 1, and the upper limit, which is 2, of the function of x with respect to x, okay? Or generally people tend to say it is actually the integral of y dx. And what is our y? We have been given our y to be 2x squared plus 3. So what we are looking for inherently is area of the integral value of the function 2x squared plus 3, and we integrate with respect to x, okay? And we have our lower limit as 1 and our upper limit as 2. Now, generally, if you want to find the integration of a function, if y is, let's say, axn, okay, the integral of y dx is going to be that a, the coefficient, multiplied by x, then we increase the power by 1 and divide by the new power. So this is means of actually going about solving for integration of a linear function, and that is what we are going to make use of in this particular case. So by the time we want to make use of that, we can say our area is nothing but, now for us to find the integration, we still have 2, then we have x, we increase the power by 1, that's 3, because 2 plus 1 is 3, then we divide by that new power, which is 3, okay, plus 3 is a constant, and the integration of a constant will just be that we'll bring the variable into it, because this is like 3 times x raised to power 0. So we still have that 3. Then x raised to power 0 plus 1 will be x raised to power 1, and then we can divide by 1. But we don't need to be writing 1, so we just have 3x. And then, since we are looking for area, we don't need the constant of integration. We just bound it by the region 1 to 2. And then this is what we need to solve for. Generally, people tend to like, okay, first they take this expression, substitute 2 into it, then minus, they take the same expression, substitute 1 into it. But you can do that. What I want to do here is that it's actually a factor equation. So I have it as 2 raised to power 3, okay, then x raised to power 3. The first case, I have 2 raised to power 3 minus 1 raised to the power 3. So already I'm taking care of both the upper limit and the lower limit like this. Then plus 3, then what's the value of x? I have 2, and then the second value minus 1. You can use the other method and you'll see that we'll still arrive at the same answer. Okay, so with that in mind, we can say 2 raised to the power 3 is 8, 1 raised to the power 3 is 1, 8 minus 1 is 7. So 7 times 2 will be 14 over 3 plus 3. Okay, so if you are looking at this, we can say we want to find the LCM, which is 3. In the first case, we just have 14 plus, now 3 is as if you're having 3 over 1. Of course, 3 over 1 is still 3. And then we can have 3 times 3, which is 9. So 9 over 3 inherently is still 3. So we are on track to say that this is nothing but 14 plus 9 is 23 over 3. And we can just find the whole number. 3 in 23, that is 7. Okay, 3 times 7 is 21. So remaining 2. So we have this as 2 over 3 square units. And you can see that this is quite close to the value we got the other time, looking at the trapezium, that the area under the graph is 8 square units. But because that is approximated, and we are having that this is 7 whole number 2 over 3, which is still approximately 8 square units. Okay, so this is how you go about finding the area under the curve, and you'll be good and fine. Student, you can try out your hand on the other case in which you first express, like in the first case, you put 2 into this bracket, then minus the second case in which you put 1 into the bracket, and you are going to see that we are still going to arrive at the same answer. All right. In this word problem on equations, we are told that in a community, men contribute P naira each and women contribute Q naira each towards the community development fund. That's a good cooperative work. Okay. Now, in a week, you have 3 men and 5 women contributing a total of 9,500. Since each man is contributing P, and we're having 3 of them, then we are having 3P. And then since each woman is contributing Q naira, and we're having 5 of them, that means we have plus 5Q. What they contributed is nothing but 9,500. Okay. And then in another week, 5 men and 10 women contributed a total of 17,500. That means we are having 5 men plus 10 women contributing 17,500. So that's a very good interpretation of what we have. Our mandate is to find the value of P and Q. So that can come out here since we are having a simultaneous equation in P and Q already. And then we have to find the total amount that will be contributed by 8 men and 12 women. No problem. Let's just see how that can be solved. Yeah, we have these 2 equations that, as I'm looking at this as, of course, we call this week 1, and then this another week, let's say week 2. So inherently, we have these 2 sets of equations that we can say we want to solve. And I want to make use of simultaneous equation. And here, I can see that I have 5Q and 10Q. If I multiply equation 1 by 2, so I want to say equation 1 multiplied by 2, okay, that will make 5Q to be 10Q. Then I can subtract. So 3P times 2 is 6P plus 5Q times 2 is 10Q is equal to 9,500 times 2. That will be 19,000. So I can call this equation 3. And with what I have here now, since I have 10Q and 10Q, I can say here, I just want to subtract. I can say equation 2 minus 3, or even I can say equation 3 minus 2. But just so students, you can follow much more directly. Let me say equation 2 that is on top minus 3 that is below. 5P minus 6P, that will be minus P, okay? 10Q minus 10Q is 0. I don't need to write that. It's equal to 17,500 minus 19,000. That will be minus 1,500, such that P itself, dividing both sides by minus 1, will be 1,500 naira. Okay? Then from here, I can now say, since I have P to be 1,500 from any of the equations, maybe from 1, I can say that 3P plus 5Q is 95. So I can say 3P plus 5Q is 95. Then if I put in the value of P, that would be 3 times 15 plus 5Q is 9,500. And then 3 times 15 is 4,005. 5Q will be 9,005 minus 4,500. So I have this to be 5Q is equal to, this will be 5,000. And then if I divide both sides by 5, Q will be 1,000. And I think this is a good means of sharing the responsibility that men are paying 1,500 naira each, while women are paying 1,000 naira each. So that is all about that. In the second case, we are asked to find the total amount that will be contributed by 8 men and 12 women. That will be 8p plus 12q. That's what we are being asked. And if we put in the value of what we got, that will be 8 times 1,500 plus 12 times what's q? 1,000 naira. So inherently this is going to be nothing but 8 times 1,500, that will be 12,000 plus another 12,000. So the contribution by 8 men and 12 women will be nothing but 24,000. So with that, we've been able to solve this word problem that is involving contribution of both men and women. I would think it's a very good idea that men and women are pulling their resources together to develop the community, just like we are doing on this channel. All right. In this question on longitude and latitude, we are told that an aircraft flies from point P, which is on latitude 12 degree north and longitude 11 degree west, to point Q, that is on latitude 12 degree north and longitude 11 degree east, in 2 hours, and then it changes its course and arrives at point S on latitude 44 degree north and longitude 11 degree east in 6 hours after leaving point Q. Our mandate is to calculate correct to 3 significant figures. First, the total distance covered, the average speed of the aircraft, and the time difference between Q and S. So let's try and locate the point P, Q, and S on our globe as given here. First, we are given the mandate that point P is on 12 degree north latitude. So normally we start from the origin, the center of the globe, and then we measure outwards. Like the latitude 12 degree north, we'll take it starting here as origin and go up, because ideally this is the north, south, east, and west. Okay, so we are taking 12 degree north, so we can append this as 12 degrees north, and then 11 degree west. West is to this side, so this can be our 11 degree west. Okay, that's the longitude. So the intersection between the longitude 11 degree west and the latitude 12 degree north will have to be our point P. So here you can just append this as point P, and then in the same way we can look at point Q. It is on the same latitude as P. That's why they are sharing 12 degree north and 12 degree north. But now Q is 11 degree east as the longitude. So this other one to the east we can take as our 11 degree east. And the point of intersection of this longitude and this latitude, which is here, that will have to be the point Q. And then we're also told that from Q, the aircraft changes its course and arrives at point S, that is now on latitude 44 degree north and longitude 11 degrees. So we are noticing that the longitude for S and the longitude for Q, they are the same. So it is still this 11 degree east. And by the time we are taking 44 degree north, that will be farther than 12 degree north that we had before. So we can take this as our 44 degrees north, and the point of intersection between this longitude 11 degree east and this latitude 44 degree north, this place, that will have to be our point S. So we have our diagram as shown here, and if you want to just look at what we are being asked, first we are being asked the total distance covered. That will be first the distance from P to Q as shown here, and then from Q to S as shown here. So the distance that is covered by the plane is first the distance covered from P to Q and then Q to S. And if you want to look at the means of finding that distance, let's try and finish up this diagram. Okay, so from here we can have some radius to the north and south pole, and this is actually radius r. Okay, this is also small r, but there's another radius we can look at from the center of the globe to the point on the longitude and latitude here. Okay, the point on the great circle, and then we can have this and this. So this other one, we are having them as the radius of the heart r, which was given as 6,400 kilometers. So our mandate here is to find the total distance traveled, and that will be the distance PQ along the parallel of latitude plus the distance QS along that longitude. So we can find that the total distance we are looking for is nothing but the length of the arc PQ plus the length of the arc QS. The plane starting from P moving to Q, that's PQ. Then from Q moving to S, that is QS. So that is very interesting. We can now go to find means of finding PQ and QS. And this is what I want to show us. So then just follow this through. For the distance PQ, if you look at what we have something like this, that this is point P and this is point Q. And then we have some angle in between them. And it's looking as if we are dividing that angle in two, in which here, from the center to the left, it is actually here, and we have measured 11 degrees first to the west, and then to the other side, we have another 11 degrees to the east. So the total angle in this case, if you are to look at it, you can say we have some alpha that we are looking at. It will be the sum of these two, 11 degrees plus 11 degrees, and that will be 22 degrees. So this is the angular difference or the angular sum, because we are even adding them. We're adding them because they are going in different directions. By the time we get to look at the second case, we'll see that we'll have to subtract because they are in the same direction. So that we cut out. So we are saying this angle here, that it is nothing but 22. And then we identify this as R, and this is also R. So the first distance PQ that we are looking at will be nothing but alpha over 360 multiplied by 2 pi r. But now, we are not giving r at all, because this r is the radius along the parallel of latitude. What we are giving is the radius r, the radius of the heart. Now, if you want to look at the two, this is going to come out very, very clearly now. If we take this as the center of the heart, the origin, and we have this, let's say this is some point T. If you look at that diagram critically, you are going to see that what we have is that this is point T, and then to the right, we have this as point Q, and then that T is also coming straight down to the center of the globe, and then we have this as the radius r that we are given. So we have this particular r here from T to Q is r, just like T to P is r, and already we have measured out the angle from that origin to the parallel of latitude. We got this to be 12 degrees to the north, okay? And then by reason of understanding of trigonometry, we know that this 12 is also the same as this angle here, that this is also 12 because it's alternate to this parallel of latitude that we're given originally. And looking at this now, what do we have? If nothing but we have SOHCAHTOA. This is actually SOHCAHTOA because it's a right angle triangle here. And we have the adjacent, we have the hypotenuse, and we have the angle. That is nothing but cos. So what we have here is inherently we have that cos theta, you can just take it as cos 12, okay? It's nothing but adjacent, which is r, over hypotenuse, which is capital R, so that the radius that we are going to be using here is nothing but r is equal to the capital R, that's the radius of the heart, cos the angle of latitude, okay? So if we have this, then our equation inherently will become something like this. So our equation now, instead of us just writing out, we can now say that is depicting that this equation is nothing that PQ is nothing but alpha over 360 multiplied by 2 pi. Instead of small r now, we have r cos theta, where theta is the angle on the parallel of latitude. So this is what we're going to be doing for PQ, and then we're also going to see what we can do for SQ, okay? Now, if you are to consider the distance from Q to S, what we have is something like this. We have this as the center of the globe, and then we have this particular arc coming like this, and we have this point first, point Q, and then on the other hand, we have point S. Now, the distance between them is this QS here, but what we are looking for first and foremost is that I want to depict how we can find that angle between them. Now, from the center of the globe to point Q, we have been given that now we need to measure that angle as the parallel of latitude. This was given as 12 degrees, okay? But then from that center also to S, we gave it as 44 degrees. And now the angle between them, this angle, if I still maintain that, I'll call it alpha. You can see that alpha is going to be the difference between 12 and 44. that alpha here is going to be 44 minus 12, and that is 32 degrees. So this angle here is nothing but 32 degrees. And then in this particular case, we noted that this is R, which is also the same as OQ. OS and OQ, they are both R. So the distance QS for this particular case, our QS is nothing but alpha here over 360, because it's just the length of an arc to multiply by 2 pi R. And that R is the radius of the arc, which we are given as 6,400 kilometers. So we have all the parameters that we need. We have gotten the angular difference, we have gotten the angular sum, we have gotten the different angles that we need. We can just put them together and try and solve out this particular question now. Going back to the formula for our total distance that we are looking for originally, you can say that total distance is PQ. What is PQ? PQ, we said it is alpha over 360 multiplied by 2 pi R cos theta, and theta is the angle of the parallel of latitude. Alpha is the angular term of the longitude of P and the longitude of Q, okay, plus the distance QS. That is actually, let me call this alpha 1, let me call this alpha 2 over 360 multiplied by 2 pi R, straight and direct. So if you want to put in those values, just like we got initially, alpha 1 is 11 plus 11, which is 22 over 360 multiplied by 2 multiplied by pi, we are given as 3.142 multiplied by the radius of the arc 6,400, then cos the parallel of latitude, which is cos 12. So this is actually PQ plus QS, and QS is the alpha 2, which is the angular difference between 12 and 44. We got that to be 32 over 360 multiplied by 2 pi is 3.142 multiplied by R is 6,400. Okay, so we can make use of our calculator to get this, to say we are having first 22 divided by 360 multiplied by 2 times 3.142 multiplied by 6,400 cos 12. Okay, so this is 2404.035. 2404, so we have 2404.035 as distance PQ, plus in the other case we have 32 divided by 360 multiplied by 2 times 3.142 multiplied by 6,400. So that is what? 3574.898. And if you are to sum the two, so this is our answer plus the initial answer 2404.035. Okay, so what's that sum? 5978.93. So this is 5978.93. But we are asked to get that to the nearest, correct to 3 significant. But we have to get that correct to 3 significant figures. So that means we need to look at 1, 2, 3 figures. Whatever is coming after, we need to round up or round down as appropriate. Now, 8 is what is coming under, and that is greater than 4. Numbers between 5 and 9, we round up to 1 and add to the number immediately preceding it. So we round 8 up to 1 and that to 7. That will become 5980 kilometers. So we have this as 5980 kilometers as the total distance that the aircraft covers in moving from P to Q and then from Q to S. So that's the solution to A part. Okay, so you can say we just got our total distance to be 5980 kilometers approximately. Now in the question B, we are told to find the average speed of the aircraft, and that average speed is going to be nothing but the total distance divided by the total time. Okay, the total time that the plane took in traversing all those journeys from P to Q and Q to S. Now, interestingly, we just got our total distance to be 5980 kilometers approximately. If you are walking, you make use of the original value, not the approximate value. So, if that is going to be the case here, we are just going to have this as what's our original value from the calculator? We have 5978.93. 5978.93 divided by, what's the total time? Initially, in moving from P to Q, it took 2 hours. Then from Q to S, it took 6 hours. So we have 2 plus 6 hours. So we have this, and we have this in kilometers. So if you want to look at that average speed, you can just say that speed is nothing but, where's our calculator? This is our initial answer. We can say answer divided by 2 plus 6 is 8. So we can just get that to be 747.36659. Give me 367. This is 747.367. But again, we are asked to get it correct to 3 significant figures. And we want to do that. We are looking at 3 significant figures. 1, 2, 3. Any number after it, we are going to round up or down. 3, we need to round that down. And rounding it down will mean down to 0. It will not have effect on the other numbers. So the average speed is nothing but 747 kilometers per hour. So that is the average speed of this particular aircraft in journeying from point P to Q and then Q to S. Then finally, in the third question, we are asked to find the time difference between Q and S. Let's look critically at this longitude. You can see that Q and S are lying on the same longitude. And for locations that are on the same longitude, they are not going to have any time difference. So we can just say there is no time difference between S and Q as asked from the question. So that is why a location like Lagos and London, they're on the same axis of longitude, and that is why they are sharing that same time zone, and there's not going to be any time difference between them. So that is all we need to do. We've answered the question holistically, and we are good and fine. Here in this question on graphical solution to quadratic equations, we are asked to copy and complete the table below for the relation y is equal to s squared minus 2x minus 3. And you can see this here is a table that we are to copy and complete. Then after doing that, we are to draw the graph of the relation using a scale of 2 centimeters to 1 unit on x-axis and 1 centimeter to 1 unit on y-axis. So our work is simplified because we're already given the scale to use. Then we have to determine the root of the equation s squared minus 2x minus 3. Okay. Then using the same as this, we have to draw the graph of y is 2 minus 2x and then deduce the root of the equation s squared minus 2x minus 3 is equal to 2 minus 2x. And finally, we have to find the minimum value of y is equal to s squared minus 2x minus 3. So let's take it piecewise. First, in the first question, we're asked to copy and complete the table. So this is the table, and there are a number of ways that you can go ahead to do that. You can either use your calculator, but in this particular video, I want to get our hands dirty. Maybe you can use the calculator to confirm. So there's this particular table of value that I'm going to find very, very useful. Why? Because all of the values of the particular equation in question, this equation, okay, all of the values are already represented there. You can see x is the variable that we have its value given to us initially, but then we're having s squared, okay, we're having minus 2x, and we're having minus 3. So those are the terms of the equation that I've already included here. And that is not the only case, because in this particular case, we're also asked to draw the graph for y is equal to 2 minus 2s. So we have y is 2 minus 2s for this particular y, but this one will correspond to this. I'm going to use two different ink so that you don't confuse them with one another. But since we are going to have two graphs, then we're also going to have two tables, and that is why this table is going to come in handy. All right, so just like we have it here, we can just use this set of values to compute what we are going to be having here. Like in the first case, when x is minus 3, x raised to the power 2 is minus 3 times minus 3. Negative signs will multiply each other to give a positive sign. So minus 3 raised to the power 2 is minus 3 times minus 3, which will be 9. So this is 9. Okay, minus 2 times minus 2 is 4. Minus 1 raised to the power 2 is 1. 0 raised to the power 2 is 0. 1 raised to the power 2 is 1. 2 raised to the power 2 is 4. 3 raised to the power 2 is 9. 4 to the power of 2 is 16. And 5 to the power of 2 is 25. Okay. Then minus 2x. Again, we need to know that we are having minus 2 multiplying each of the values of x that we have in this table. So minus 2 times minus 3. Again, like I said before, negative signs, they will multiply each other to give a positive sign. So here it will be minus 2 times minus 3, and that will be 6, okay? Minus 2 times minus 2 is 4. Minus 2 times minus 1 is 1. Minus 2 times 0 is 0. Minus 2 times 1. Now, since all of these are positive numbers, a negative number multiplying a positive number will always give a negative number. So here, we are going to have minus 2. Minus 2 times 2 is minus 4. Minus 2 times 3 is minus 6. Minus 2 times 4 is minus 8. And minus 2 times 5 is minus 10. Okay? Then moving on, this is just a constant. It's not having the variable x at all. So all across this row, we are going to have minus 3 as a constant that is featuring all across the range of values for x. And then to find the value of y for the equation y is equal to s squared minus 2s minus 3, what we do is we add these values that we have in red, we add them together. Like in the first case, 9 plus 6 is 15, 15 minus 3 is 12. So that is confirming that this value here is correct and we are on track, okay? 4 plus 4 is 8, 8 minus 3, that is 5, okay? 1 plus 1 is 2, 2 minus 3, that is minus 1, 0 plus 0 minus 3 is minus 3, again confirming that what we have is also on track. 1 minus 2 minus 3 is 1 minus 5, and that is minus 4, okay? 4 minus 4 is 0, 0 minus 3 is minus 3, 9 minus 6 is 3, 3 minus 3, that will be 0, 16 and minus 8 minus 3, okay? Minus 8 and minus 3 will constitute minus 11, 16 minus 11 is 5, which is confirming that we're on track. Then we have minus 10 and minus 3 is minus 13, 25 minus 13 is 12. And if you look at these values, you will see that there is a symmetry, because like here we have minus 4 as the midpoint, then minus 3 to the left and minus 3 to the right. And here, look at this now. Now, the main fact that we understand that is a quadratic graph and it's supposed to be symmetrical is showing us that we have made a mistake here, okay? And what is that mistake? I think it is coming here in this particular value. Minus 2x will be minus 2 times minus 1, and that will be 2, not 1. So in that case, I need to erase this particular value of 1, okay? And then put in the right value of minus 2 times minus 1 is 2, such that here, these are little tricks that students, once you know them, you'll be able to actually work your way very, very effectively. 1 plus 2 is 3, 3 minus 3 is 0. So you can see that symmetry I'm trying to talk about, okay? So let me just rub off this because you don't need that. So you can see the symmetry I'm trying to talk about, that once you have minus 4 at the middle, minus 3 is flanking it, 0 is flanking that, 5 is flanking that, and then 12 is flanking that. Those are peculiar nature to a quadratic graph in which you can have a symmetric set of values, one in the positive direction, the other in the negative direction. So we are through with this particular equation, y is equal to s squared minus 2x minus 3. Now, we want to move on to this other equation that we have here, that y is equal to 2 minus 2x. Now, in the first case, you can see that this 2 is a constant, so we only have 2 all along that row. Since it's a constant, it's not going to be affected by the value of x, it's just 2 all along. And now we have minus 2x. But interestingly, look at this. This particular row, this row, is already giving us the value of minus 2x. So we just need to repeat that this will be 6, 4, 2, 0, minus 2, minus 4, minus 6, minus 8, and minus 10. Okay. And then to compute the value of y, for y is equal to 2 minus 2x, we only need to add the values in blue, okay? We are adding them because we already noted the negative sign here. So all we just need to do now is just to add. Now 2 plus 6 is 8, 2 plus 4 is 6, 2 plus 2, 4, 2 plus 0 is 2, 2 minus 2 is 0, 2 minus 4 is minus 2, 2 minus 6 is minus 4, 2 minus 8 is minus 6, 2 minus 10 is minus 8. Again, look at the consistency with this value. You can see that it is looking like an arithmetic progression with a common difference of 2. The first term is 8, and with 2 as a common difference. Okay, yeah, minus 2 as a common difference, okay? So we're having 8 minus 2, 6, minus 2, 4, minus 2, 2, minus 2, 0, minus 2, minus 2. minus 2 minus 4, because it's a straight line graph and that has to be linear. Okay, so these two are the equation that we are requested to get. Here, this particular one is the table of value for y is equal to 2 minus 2x. Okay, and then the one we did initially, the one in red here, is one for y is equal to s squared minus 2x minus 3. Students, there are some very key things you can already note from this particular question. For example, we are asked to, in this question, we are asked to deduce the root of the equation where both of them are equal. We can look at the set of values and see if do we have any point at which both of them are equal, that the value of y in the first one is equal to the value of y in the second one. Okay, if we cannot see it here, good, we'll get to see it on the graph. But interestingly, looking at this particular question here, that we are to determine the root of the equation s squared minus 2s minus 3. If you look at this particular graph, you can see that in two places the value of y is 0, first here and then here. Okay, those two places correspond to where we have the root of the equation, and those roots will be minus 1 and 3. Okay, so if you understand your graph, you'll be able to note those ones already, but no problem, we're also going to see it directly. Now, the other thing I promise is that we're going to check with the calculator to see if what we got here is correct. So let me fire up my calculator here. Okay, so I'm going to fire up the calculator, and these are the two equations that we need, this one here and this one here. So we go to mode, and you can see on the scientific calculator 7 corresponds to table, and then in the first case is looking for the function of x. The function of x is x raised to power 2, and this is x on top of the close bracket button. So it's written in red. For me to get that, I press alpha close bracket, then raised to power 2, okay, then minus 2, again 2x, then minus 3. Okay, that's my equation. Then it's asking for g of x, meaning that do I have another function that is defined in variable x? Yes, I do. It is 2 minus 2. So I say 2 minus 2x. Okay, so I press equal to. The start value is asking me for the first value of x. In this case, it is minus 3. Okay, the end value is 5, and oh, interestingly, I have 5. Then the step, the increment, the incremental value, like the common difference. Now you can see it's also in the step of 1, like minus 3, minus 2, minus 1, 0, 1, 2, 3. So the difference in each subsequent values is actually 1. So 1 is okay. I can press equal to, and it's going to give me my table. Okay, so you can see 12, 8, 5, 6, 0, 4. If you just move down for x here, okay, for x is 1. Let's start from there since it's showing already on the board. For x is 1. When x is 1, what's the first function? It is minus 4. You can see here is minus 4. And what is the second function? It is 0. Okay, when x is 2, you can see 2 here. We have minus 3 and minus 2. You can see minus 3 and minus 2. And when x is 3, you have 0 and minus 4. Look at this, 0 and minus 4. Okay, when x is 4, you have you have 5, which was predefined for us. We have 5 and minus 6, 5 and minus 6. And when x is 5, you have 12 and minus 8, 12 and minus 8. So just like that, you've seen the two methods that you can use to actually get your table of values. If calculator is allowed, you can go ahead and use your calculator to solve. If it is not allowed, then you can get your hands dirty and solve the question, because now you don't really have any excuse. So having gotten our table of values, we can now see how we can progress with this particular question. All right, so here we have our graph sheet, and then we have our table of values. The one in red is corresponding to s squared minus 2s minus 3. The one in blue is corresponding to y is equal to 2 minus 2x. And then we have been given the scale originally. We are told that 2 centimeters should represent 1 unit on the x-axis. That is the horizontal axis. Okay, 1 centimeter to 1 unit on the y-axis. That is the vertical axis. So we need to see where our origin is going to be. Now, for the values of y, we can see that the maximum is 12 and the minimum is minus 8. Okay, so we should find a way to represent that accordingly, that 12 and minus 8 should reflect on this particular graph, and it is 1 centimeter to 1 unit. So on the graph, where is 1 centimeter? From the tick here, from this tick line to this tick line, that's 2 centimeters. Okay, so half of it will be from here to here, so this will be 1 centimeter. So they say 1 centimeter to 1 unit. So it's as if you are saying 2 centimeters to 2 units on the y-axis, whereas on the x-axis 2 centimeters is from here to here. So that's 2 centimeters to 1 unit on the y-axis, on the x-axis. Now, on the x-axis, we have our least value to be -3, our highest value to be 5. How many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divisions. And this graph is actually 10. Because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, that is going to cater for x effectively. However, talking about y here we have values that we want to represent. Least is -8, highest is 12. Okay, and 2 centimeters. If you say we want to take -8 here, let's say -8, -6, -4, -2, 0, 2, 4, 6, 8, 10, 12. Okay. So this is -8, this is 12. That's good, but we can just take -8 here so that 12 will just land there, and I think that will centralize our graph better. Okay. Horizontal axis, and then our vertical axis, and we can just label them that yes, this is 0, and this will be 2, 4, 6, 8, 10, and 12 on the y-axis. Okay, so we have -2, -4, -6, -8, and that is catering for our least value and our highest value. Okay, and then on the x-axis, the horizontal axis, we have 0, 1, 2, 3, 4, 5, and you can see this is better now, and -1, -2, -3. So we've been able to manage our space quite well with the way we didn't just centralize with a typical way in which you just say centralize everything. No, we cannot afford to do that in this particular case. So that's why just shifting the center to this particular location has helped us to map out correctly what we want to have. So in the first case, let's look at the equation, the quadratic equation. Y is x squared minus 2x minus 3. When x is -3, y is 12. So here, this is -3, and I think I want to use blue ink for that. This is -3, okay, and then this is 12. The point of intersection is a point of interest for us, so I can just denote that as -3 and 12. And then when x is -2, y is 5. -2 and 5. 5 is between 4 and 6, and it is this thin line here. So I can say that this is -2 and this is 5. Okay, so I can just speed it up because we can easily trace them here. They are whole numbers. When x is -1, y is 0. So this is -1 and y is 0 is exactly on top of that -1. Okay, when x is 0, y is -3. This is 0 for x. Y -3 will be between -2 and -4. So we are looking at something here. Okay, and then when x is 1, y is -4. This is 1, and here is -4. You can just trace it like this. You can see, and then -4. That point of intersection is where we are looking at. Okay, so you can see it is here -4. Then this is the symmetry I was talking about when we're computing the table of values. Now, when x is 2, y is also again -3. So this is the -3, 2 for x, -3 for y. Then when x is 3, y is 0. Here, when x is 4, y is 5. We've gotten 5 initially too. And you can see our understanding of how a quadratic graph normally looks like, how it's helping us to extrapolate our values quite easily and quickly. 5 and 12, 5 and 12. So we have that here. Okay, so having those points, what is now expected of us is to join them together. Students, you can make use of your French curve, or like we used to do in those days, you can make use of your broomstick. If you are using your French curve or your broomstick, you should have something that looks like this as the line of best fit, joining all of those points together. Okay, and then from the question, we're told that we have to find the root of the equation. So from the question, the root of the equation, the root of the quadratic equation, of the equation x squared minus 2x minus 3 from the graph from the graph, you can see here, it is the point where the quadratic curve cuts the x-axis, and here it is -1 and 3. And actually, if you know how to read your table very well, you can see on the table of values, in this particular case, y is 0, and here y is 0, corresponding to the value of x to be -1 and 3. That is the correct thing. But as a rule of thumb, generally, you should ensure that you always label your graph. So here, you should write that this is y is equal to x squared minus 2x minus 3. Please, that would be very good, and it will earn you your full mark. Okay, so having done that, we are also asked to plot the table. We are also asked to plot the graph for the linear equation y is equal to 2 minus 2x. Now for those, you can see is this second set of values for y, the one in blue, that we are going to use. So we can actually go ahead to also do that. When x is -3, y is 8, -3 and 8. I think by now we should be able to get that easily. This is -3 and this is 8. Okay, this point of intersection is our interest, and we can just note it, -3 and 8 here. We have -2 and 6, and you can see here is the point of intersection of the two. Okay, we have -1 and 4, that is here. We have 0 and 2, 0 on the x-axis, 2 on the y-axis, and you can see it's already forming a consistent straight line. We have 1 and 0, 1 on x-axis and 0 on y-axis, so that will be here. We have 2 and -2, that will be featured here. We have 3 and -4, okay. Then we have 4 and -6. Then we have 5 and -8. So already we have that as our set of points that we now need to join together. It's going to be a straight line, so you can just start by drawing a straight line just to get all the points in question, and that is as good as it gets. Okay, that's as good as it gets. Then, as a rule of thumb, I told us before, we should ensure that we always label our graph. So this particular graph is that we're having here, we have y is equal to 2 minus 2x, 2 minus 2x. Okay, so yeah, we've been able to come up with the other graph, and that is also a done deal. Next, we are asked to find the root of the equation x squared minus 2x minus 3 is equal to 2 minus 2 minus. So for x squared minus 2x minus 3 is equal to 2 minus 2x, the solution is given as. Now, what is going to be the solution to this particular question? If they are saying the two equations are equal, that means they are referring to the point where they overlap. Okay, and if you want to get that, if you want to get the point where they overlap, here we can look at the point of intersection here. Okay, and then we can trace to the x-axis, because at this point you can see that the quadratic graph and the linear graph, both of them are intersecting here and they're intersecting here. Okay, so at those 2 points, let's just trace it down to the x-axis and we'll find the solution set for such. So you can see I'm just using my very thin line. Okay, I think this is quite good now. So our mandate is to look at that particular point and try and see the value that we are having here and the value we are having here. Okay, so I will zoom in and looking at what we just did, we can see that this is -2, this is -3. Directly in between them is -2.5, meaning that the gradation here is -2.1, -2.2, -2.3, -2.4, -2.5, so that it will eventually end at -3. So is a single decimal point that is corresponding to each of the small boxes of our graph. Okay, so here we have minus 2.1 minus 2.2 minus 2.3. So here this is minus 2.3, and here we have 2.1, 2.2 is between 2.2 and 2.3. Okay, you can also say maybe that is like 2.2. Okay, it's closer to 2.2. So we can say that solution for x squared minus 2x minus 3 is equal to 2 minus 2. The solution is given as minus 2.3 and 2.2. Okay, so this is another solution that we're asked to find. The other one we have been able to find as this. Okay, here is another one, but we can check. Okay, that's the beautiful thing. If you know what we are doing, you remember that our calculator can be used to solve for set of equations like this, and so we are going to do that right now. Question to see what is going to give us. Okay, so here what I'm going to do is I'm going to write the equation like above. Our close bracket is x, so x raised to the power 2 minus 2x minus 3 is equal to 2 minus 2x. Okay, so I can use that shift calc, which is solve, to try and solve for x. Now we have two values, and I cannot just take 0 because it can either go in the positive or negative direction. For me to pick my initial iteration, I need to pick a number greater than the suspected positive value, and then another number less than the suspected negative value. So I'm going to pick, let's say, since I have 2.2 and minus 2.3, I can pick 4 and minus 4. Okay, so for the positive side, I want the initial value to be 4. So look at this. Is this not interesting? The calculator is telling me that the solution is 2.236, and of course we are looking at 2.2. The margin for error allows that we're actually right on track. Okay, but if you also want to solve for the other value, I can again do shift calc. But now if I want to use a negative number, so I want to say minus 4 should be the initial starting point of the iteration, and then look at this, it's giving me minus 2.236. So having minus 2.3 and 2.2 is quite on track. There is a margin for error that will be allowed in the exam, and this is showing that our solution is on track. Okay, and then finally we are asked to find the minimum value for the quadratic equation. And looking at this graph, look at the highest value we have for the graph within the range of values we have from x is minus 3 to x is minus 5. You can see that the maximum value is 12 when x is minus 3 and when x is 5, and the minimum value is actually here. It is here. Okay, and that is minus 4. That's the point at which the quadratic graph actually makes a turn and started going back to increase in value. So from the graph, the minimum value of y for the equation y is equal to x squared minus 2x minus 3 is nothing but minus 4. So with this now, we've been able to effectively look at the question, solve them, and then we're arriving at our answer as requested. All right. We have this question on matrices that we'll have to find the inverse of the matrix A, in which A is given as a matrix with elements 6, 11, 1, and 2. And we're to solve the matrix equation AX is equal to B, where X is XY, and B is 29, 5. Okay, very good and very interesting. I just want you to know that to get the inverse of the matrix, this 2 by 2 matrix is going to be 1 over the determinant of the matrix A multiplied by the adjoint of A. So how do we get the determinant here? So for us to get the determinant of matrix A, that is going to be the product of the elements in the leading diagonal, that's the product of 6 and 2, minus the product of elements in the other diagonal, that is 11 and 1. So what we are going to have is 6 multiplied by 2 minus 11 multiplied by 1. So this is 6 times 2 is 12, 11 multiplied by 1 is 11. So the determinant of A is 1. Okay, that's our very first step. Now, how do we get the adjoint of the matrix A? That is going to be, just observe this. While we have elements in the leading diagonal, we are going to swap their position. So we say this is 2 and 6. Then for the other diagonal, we need to put negative sign in front of those elements. So this is the adjoint of A, such that what we are looking for, the inverse of A, so this is not A, this is A inverse, okay? So the inverse of A is going to be nothing but 1 over the determinant, which is 1, multiplied by this particular adjoint, that is 2 minus 11 minus 1 and 6. Okay, so this is nothing but 2 minus 11 minus 1 and 6. So this is A inverse, and we are good to go. Now in the second question, we are asked to solve the matrix AX equals to B, where X is XY and B is 29, 5. So students, you can as well just multiply this matrix A with XY to get a set of simultaneous equation, equate the first line to 29, the second line to 5, and that will be good. But since we're having this opportunity to work with matrices and also have a question in which we want to solve an equation with it, I think I want to use the matrix method. And this is what you need to note is that given this equation, AX is equal to B, we have AX is B. I can pre-multiply both equations by the A inverse, so that I have A inverse multiplied by A multiplied by X is equal to A inverse multiplied by B. Now, why did I say I pre-multiply? I pre-multiply because for this left-hand side, A inverse and A, they are going to be the identity element I, which is just synonymous to 1, that's unitary, okay? But in this particular case, this is a point of interest. A inverse, we can see, is a 2 by 2 matrix, 2 rows and 2 columns. But B, we are given that B is 2 by 1, okay? And as a rule of thumb, whenever you are multiplying matrices, the number of columns of the first matrix here, that's going to be A inverse here. The number of columns, 1, 2, must be equal to the number of row of the second matrix, and that is B, 1, 2. So that is a rule that is helping us to pre-multiply. And since we are doing that, that means we can just say, for this particular question, what we have is that A inverse multiplied by A, already I said, is identity matrix I, which is just like 1. So here I can say X is just going to be, what's A inverse? A inverse is what we just got here as 2 minus 11 minus 1 and 6. And then what is B? B was given to us as 29 and 5. So what we have here is just to multiply out this in such a way that it can give us the value of X. So that is going to be, we multiply by multiplying the row, multiply by the column, first row, column, and then second row also with the column. Okay, so if we want to do that, that means what we are going to be having is something like this. We have 2 times 29, 2 times 29, 2 times 30 is 60. So if you take 1 out, it will also affect the product, so that will be 58, okay? Minus 11 times 5, that will be minus 55, okay? Minus 1 times 29 is minus 29. 6 times 5 have a plus 30. Okay, so this is nothing but 58 minus 55, that is 3. Minus 29 plus 30, that is 1. So this is what we have. And since X itself is actually XY, let me just move this. So you can say this is nothing but XY, such that X, the value of X is 3 and the value of Y is 1. But since we are asked to solve the matrix equation X, so we can as well just leave it as this. And it's our understanding of the product of matrices that we can pre-multiply with the inverse of A to actually solve this that we are applying here, and you'll be good and fine, and your work is done and dusted. All right. Here in this question on arithmetic progression, we are told that the first and last terms of an arithmetic progression are 5 and 9 respectively. So we can just say we have our A, the first term is 5, then the last term L, that is 89. So if the sum of the AP is 611, the sum to some number is 611. We are now asked to find first the number of times in the AP and the common difference. Let's look at how we can solve this particular first question. There are two formulas that we can use to evaluate the sum, and the less common one is that the sum of the first n terms is n over 2 multiplied by the sum of the first term and the last term. If you recollect, the last term, which will be the nth term, will be a plus n minus 1d. So if this is adding to this a, we have it as 2a plus n minus 1d, and we still have n over 2. So that is the other formula that we have, that inherently Sn is also n over 2 into 2a plus n minus 1d. So this is generally what students make use of, but is also an expression of this, that the sum of the first n terms of an AP is n over 2, where n is the number of terms multiplied by the sum of the first term and the last term. So we will make use of this very first one here, and then we can say that we have the sum we are given as 611. We are looking for the number of terms n, so over 2 is a. What is a? A was given as 5, L was given as 89. So therefore, if you cross multiply 2 times 611, okay, I can just say n in this case will be 2 times 611, 611 times 2 over 5 plus 89, that will be 94 over 94. And here we can cut, we can say 2 can go here 1, 2 in 94, that will be 47. Okay, 47 and 611. I think since 1 is there, 13 should be going, like you say 47 times 13, 3 times 7 is 21, remaining 2, 12 plus 2, 14, then 47, good. So this is 1, 4 plus 7, 11, remaining 1, 5, 6, so good. This is quite good. So 47 can also go in 611, and that will be 13. So the number of terms that we are looking for is nothing but 13, okay? So that is the first solution. In the second case, we are asked to find the common difference. Since for this particular equation, we have been given the last term, we can say Tn is equal to, generally by our reason of equation, it is a plus n minus 1d. Now, in this particular term, we want to take the 13th term. The last term will have to be the 13th term. So here, we can say that T13, what were we given as T13 is 89, okay? Then A, we were given as 5. We just got our n to be 13, and then D is what we are looking for. If we just bring in all of these parameters that we have, we can say 89 is equal to A is 5 plus n minus 1 will now be 12d, such that 12d will be, well, we take 5 to the other side, it will be 89 minus 5, and that will be 84. Then d itself, in that case, will be 84 over 12. 84 over 12 is nothing but 7. So the number of terms for this particular AP is 13, and the common difference is 7. And with that, we've been able to solve this question as requested perfectly, and we are good to go. In this question, we have this ungrouped data set in which we are asked to construct a frequency table with a given class interval here, 1 to 20, 21 to 40, and subsequently we have 41 to 60, 61 to 80, 81 to 100, okay, because I'm seeing 90 here. Then we are to use an assumed mean of 30.5 to calculate the standard deviation of the distribution, and then find the probability that the student selected at random scored above 40 marks. So the first mandate for us is to get a frequency table which we are going to use to calculate the standard deviation of the distribution, and quite cut out for us is our work here, in which first and foremost we need to use the class interval 1 to 20. So on this score, we need to put this is 1 to 20, then 21 to 40, 41 to 60, 61 to 80, and then 81 to 100. And then we need to find the tally, and we need to do the tally just manually and drill down that what are the numbers between 1 and 20 that we can see here. In the first row, we have 12, we have 14, we have 20 itself, we have 11, and then we have 19 that will cross out to make it 5. Then we have again another 19 in the second row, and then we have 10 in the third row. So the frequency here is 7, okay. So for data entries from 21 to 40, we have, in the first case, we have 40 itself, we have 22, we have 34, we have 26, we have 32, that makes it 5, okay. And I think that is all on the first row. On the second row, we have 31, we have 35, we have 30. Okay, that's all on the second row. On the third row, we have 21, we have 38, that means another 5. We have 24, we have 27, and we have 32. So we have 5, 5, and 3. So we have 13. So this is how you go about doing this, students. You could as well have marked it on the sheet, but if you are doing that repeatedly, you may get clogged. Or maybe you can use your pencil for each particular class interval, and then you erase it and go back. Okay, maybe you can do that for 41 to 60. So for 41 to 60, let's look. On the first row, are we having anything between 41 and 60? None. On the second row, yes, we have this to 60, we have this 41 to 60, we have this, and I think that is all. Okay, so for 41 to 60, we're having how many entries? 1, 2, 3, 4, 5. So you can just 1, 2, 3, 4, 5. This is 5, and then you need to erase all of this. So that maybe you can just do that in your exam also. Now for 61 to 80. For 61 to 80, we are going to look at, okay, how many 61? On the first row, we have this, 61 to 80, okay? We have this, any other one, 61 to 80, okay, we have this. So we have 1, 2, 3, 4. So just 4 entries in those, 1, 2, 3, 4. So this is 4, and then 81 to 100. How many of such do we have? 81 to 100. I'm seeing only this 90. Okay. And then we can just say this is 1. So our frequency is 1. So that's how you go about getting the frequency. And you can also sum the frequency. Okay. Like 7 plus 13, that is 20, plus 5, 25, plus 4, 29, plus 1. This is 30. So summation F is nothing but 30. Okay. Now I want to get the mid value for this particular score. That's going to be the computation for X. So if you want to get that mid value, you can just look at here on the class interval 1 to 20. Just find the average. 1 plus 20 over 2. That will be 21 over 2, and that will be 10.5. And then sequentially, you're just going to have an increment of the class size is looking like 20. So you have an increment of 20. So the next one will be 30.5 and co. So you just want to do that. You can say this is 10.5. For this one will be 30.5. Then we have 50.5. We have 60, not 60. We have 70.5, and here we have 90.5. Okay. Now we need to get the deviation, because for the formula for the standard deviation, it is summation fd square over summation f minus the square of summation fd over summation f, where d is the deviation between the mid value and the assumed mean. And if you recollect, we have been given the assumed mean as 30.5. So A was given as 30.5. So here, this d that we are looking at will be each of the data entry value for x minus 30.5, like 10.5 minus 30.5. We are going to put that down, and that will be 20 minus 20 to be precise. Okay, 30.5 minus 30.5 is 0. 50.5 minus 30.5 is 20. 70.5 minus 30.5, 40. 90.5 minus 30.5, that is 60. Now we can find the square of our d. Okay, the square of d, the square of minus 20 will be 400. Because we are making use of it here, we need summation fd square. Okay, so the square of 0 is 0. The square of 20 is 400. The square of 40, that's 1600, and the square of 60, that is 3600. So now let's get the product of our f and d. This column and this column, that will amount to fd, and we'll do it to compute that because we need it in our equation. 7 times minus 20 is minus 140. We need to be careful here because we are looking at this and this. Okay, maybe that will be a very good guide. 13 times 0 is 0. 5 times 20, that is 100. 4 times 40 is 160, and then 1 times 60, that is 60. Okay, so we are good to go with that. We have gotten that as appropriate. Then we need to also get the summation of that particular data entry. Okay, we have minus 140, we have 160. So that will remain 20. 100 plus 20 is 120. 120 plus 60, this is 180. So this is 180. And 180 is actually this is summation FD. That's 180. Then we need to also look at F, the frequency, multiplied by the square of D. So we can take those two columns. 7 times 400, that is 2,800. 30 times 0 is 0. 5 times 400, that will be 2,000. Then 4 times 16, 4 and 16 is like 8 and 8, that is 6,400. Then 1 times 3,006, that is 3,600. And again, we have gotten the column that is corresponding to FD square. We also need to sum it. Like here, I'm seeing 6,400 and 3,600. The two combined to be 10,000, plus 2,000 is 12,000, plus 2,800. This will be 14,800. And this is amounting to summation FD square. Okay. So once we are noting that, just want to note that already. So at the base, what I'm having is that is the summation here. This last row is actually the summation. Like summation of F is 30, and then summation of FD, that is actually 180, and the summation of FD square is 14,800. We are using an assumed mean of 30.5. That's how we got all of this. So we can go back to try and solve for our standard deviation, to say that standard deviation will now be the square root of, let's impute all these values that we're having now. What's the summation of FD square? That is 14,800 over summation F we got as 30 minus the square root. What's summation FD? That is 180 over summation F, that is 30, but we are squaring all of this. So if we are doing this, we can say from here we can get our standard deviation to be, let me bring in our calculator now. So we have 14800 divided by 30. Okay, this is, or let me just write everything together. Minus 180 divided by 30 this to power 2. So this is 457.3. I'm going to find that square root. So this is the square root of 457.3. And if I'm to evaluate that, I'm going to say square root of the answer I just got. So this is 21.385353. I can just approximate it to 21.39. Okay, so this is 21.3853, which is approximately equals to 21.39. So this is the standard deviation for this particular data set as required. All right. So now in the second part, we're asked to find the probability of selecting a student that scored above 60 marks. Okay, that's what we are looking for in this second case. That is going to be the frequency of those that scored above 60 over the total frequency that we have. So frequency of those that scored above 60 divided by the total frequency will give us this probability. And if we are looking at the table, let's look at the table. We can see that here, those who scored below 60 are in this range 1 to 60. Okay, those who scored above will be from 61, and their frequency will be 4 plus 1. All right, so you can just say this is nothing but 4 plus 1 divided by what's the total frequency? 30. So this is 5 over 30, and 5 over 30 is nothing but 1 over 6. So the standard deviation is 21.39, and the probability of selecting a student that scored above 60 marks is 1 over 6. All right. And with that, we have come to the end of this beautiful lesson in which we have looked at all the 12 questions from the 2021 NECO General Mathematics exam paper, and we have touched on so many things which we believe you also find useful if you are preparing for any grade 12 exam. Talk about your WAEC, NECO, GED, GCSE, IGCSE, and the likes. And we want to believe that this is going to go a long way to help you gain that academic excellence that you are looking for. And with that, our mandate will also have been achieved of preparing you for excellence, even as you're also putting in the effort to gain that excellence. It's been a wonderful journey. We wish you the very best. Don't forget to subscribe to the channel. Leave your comments below in the comment section. We look at all of them and we respond appropriately. And don't forget to like the video and share with your friends, share with your loved ones. It's DaveTuts Academy. And until next time, God bless you.